Hello everyone, today we will be solving the classic LeetCode problem to sum. So let's understand this problem. Given an array of integers, our intention is to find two indices in this array so that the numbers present at those indices sum up to the target. Let's illustrate this example. In the question it's also given that there is exactly one solution and we may not use the same element twice. So these constraints make it easier to solve as compared to the other versions of this problem. The simplest way to solve this problem is to check every possible pair of numbers. Say first we have the number 2. We need to check whether 2 plus another number, say 7, add up to 9 or not. In this case, they add up to 9. So we will return immediately. But if it was not the case, in that case, we would have checked 2 plus 11 add up to 9 or not. Similarly, 2 plus 15 add up to 9 or not. So this we have checked for the first number. Now after this, what we will do is, we will move to the second number, that is 7. Then 7 plus 11 is equal to 9 or not. Similarly, we will check 7 plus 15 add up to 9 or not. One thing to note is we will not check 7 plus 2 because we have already checked 2 plus 7 in the previous iteration. As we are not using any extra space, so the memory complexity is O of 1. The time complexity of this brute force solution is O of n square, which is not very efficient and we can do better than this. So let's first code up this brute force solution and then move to the optimized one. But it's better not to code the brute force solution in interviews, but this is just for reference. So this is going to be very simple, just two for loops. For I in range, len of nums, the second pointer j will go in the range I plus 1 to length of the array. So by this condition, it is ensuring that we are not checking the previously seen values. Now the next condition is simply to check if nums of I plus nums of j matches the target. In that case, we will directly return a list containing these two indices. The outer return statement is not necessary because the inner return statement will anyways get executed, as there is definitely one valid answer as per the question. So let's run this and check if it works. This runs fine, but we can do better than this. So let's move towards the optimized solution. The solution for this problem can be very easily optimized using a hash map. What if while scanning through this list, we can know that the complement of the current number is already seen or not? For this, we will use a hash map in which we will store the numbers as keys and their indices as values. Say when we scan through 2, what can be the pair of 2? The pair of 2 will be 9, that is a target, minus 2. So while scanning, what if we can check if 9 minus 2 is already present in the array or not? This can be done very easily using hash map. Any lookup from the hash map can be done in constant amount of time, which makes this approach very efficient. But if we add all the elements initially to the hash map, then this may need some more bookkeeping. So a better approach will be to build the hash map while scanning through the list in a single pass. So what we will do is, first time when we reach 2, we will see that 9 minus 2, that is 7, is not present in the hash map. So it will just move to the next iteration, and before moving, we will store the current element 2 as key in the hash map and its index 0 as value. Now we have moved to the second element, that is 7. So now we will check 9 minus 7 is already present or not. So that is, we are checking for 2 in the hash map and we can see that 2 is already present. So we can directly return the output that is needed. So we can directly return the indices as 0, that is 2's index, and the current index, that is 1. So this will be the result for this example. If we had not found the result, we would have repeated the same approach, like adding 7 and its index to this hash map. The time complexity of this approach is O of n, as we are doing this in a single pass. As we are using extra space for this dictionary, so the memory complexity is also O of n, because at most we may need to store n-1 elements in this map. Now let's jump to the coding. We will be using a dictionary in Python which is equivalent to Hashmap in other languages. Dictionary will contain the key value pair number to its index. Now let's iterate through the list of numbers. So for index, comma, number in enumerate nums. Using the enumerate function, we can very easily get the index and the number at the same time. Now we need to check if the complement, that is the target minus the current number, exists in the scene map. If it exists, we will directly return index of that value. It is scene of target minus number and the current index. But if it is not present in the scene map, then we will continue and add the current number and its index to the map. This return statement is not necessary for this question, as the inner return statement will definitely execute as there is exactly one solution. So let's see if this works. We can see that this is working and is quite efficient. If this was helpful, do consider liking this video and subscribing DKodeTree. Thanks for watching. See you in the next video.